The next aspect of substitution mechanism or substitution reaction mechanism. Under substitution, we have done free radicals, abi? But let me rub everything for the convenience sake self. Let me rub everything. I will just be taking one after the other when we need it. So let me rub it. Is elimination electrophilic? Is an electrophilic substitution reaction mechanism. A split substitution reaction mechanism into three. If attacking reagent or reagent is free radicals, we call it what? Free radicals substitution reaction mechanism. If attacking reagent is what? Is electrophile, we call it what? Electrophilic substitution reaction mechanism. If nucleophile serve as what? Attacking reagents of the reaction, we call it what? Nucleophile substitution reaction mechanism. I've explained the free radical substitution reaction mechanism. The next one now is what? Electrophile substitution reaction mechanism. Electrophilic. Electrophilic substitution reaction mechanism. Please, as we all know, what is attacking reagent here? The attacking reagent is what? Electrophile. Abi? Or when a substitution reaction is initiated by what? By electrophile, it will become what? Electrophilic substitution reaction. And in this case, I would like to give you two examples for it. The number one, the first example that I will release here, first what? Example on this, which is example one. On this, it's bromination of benzene. Bromination of what? Of benzene in the presence of iron 3 chloride as catalyst. It will give us what? Bromobenzene and hydrogen bromide. Let's check it. The what? The example is the bromination of benzene. The bromination of benzene. Of what? Of benzene in presence of iron 3 bromide. This iron 3 what? Bromide serve as what? Catalyst to obtain bromobenzene and hydrogen bromide. Look at this now. This reaction, this is the equation for this reaction. This is benzene. What? This is the best method way of what? Of drawing what? Benzene. Put ring at the what? At the middle. Is more available than using what? The bond. If this benzene reacts with what? Bromine in the presence of what? What is the catalyst there? I said iron what? F2Br3 as catalyst, and the product given here, it will give us what? Br plus what? HBr. So this is what? Benzene. This is what? The what? Benzene. Good. This is what? Bromo, then what? Benzene. This bromine here is B2. Yes. The problem now is this now. This is the normal reaction. Yeah, let us look at the mechanism of this reaction. The mechanism of what? Of this reaction. Make what? Mechanism of the what? Of the reaction. Yeah. Notice this reaction now, we want to look at the what? Is mechanism. So the mechanism of this reaction is comprised of 3 stages. The first one, step 1, formation of electrophile. Step 2, the formation of what? If electrophile form in step 1, step 2, the electrophile we react with what? With benzene at step 2. At step 3, the hydrogen ion will leave the benzene and will leave the what? The benzene and react with catalyst to form HBr. How many steps? I said we have in the mechanism 3 steps. Abi? The first one, yeah. Let me say what? Step what? Step 1. Step what? Step 1. What is step 1 said? See it here. In step 1, I said we have formation of what? Of electrophile. We have for what? Formation of electrophile. Where can we get our what? Our electrophile from? Is from what? This is substrate. This is what? Reagent. So we get our what? Our electrophile from the what? From the reagent. By doing that, what are we going to have? Look at it here. We have bromine. The bromine is B2. Br, Br. This is how we write it here. What is catalyst? This is catalyst here. And plus catalyst Fe Br3. As we all know that is what? Catalyst does not participate in what? In the reaction. So the one electron moves to this side and the one electron moves to this side. No, we are not dealing with homophilic. I'm dealing with what? Heterophilic, which is what? Nucleophile. The own electron, the bond electron, the own what? The bond electron we have, we what? We shift to this B. If they shift to this B, at the end of the day, this one will become positive. Here we have what? Negative. So when they shift to what? The bond electron should shift to what? To this B. It will have positive, negative, Abi. And here we have what? Positive. And this, everything we have here again, this B will now come back towards to this catalyst. The B will now come back to the what? To the catalyst. As a result of that, we are going to have what? Going to have this one that is lose the bond electron. We have Br, it will become Br positive. And this one is negative. It will now react with this, the catalyst. It will now give us what? What is catalyst? It will now give us plus Fe Br, instead of 3, this attached to it Br4. And then you now put general market there minus, because of the what? This binary that is what? Is gained here. So what we need here now, our major interest here is what? Is this electrophile formation of what? Electrophile. That we are done with what? Step what? Step 1. So in step 2, Step what? Step 2. Don't forget, this electrophile that's formed here in step 2 will now attack the what? The benzene. The electrophile that is formed attack the what? The benzene to form carbonium ion. Should I write it down? Yes, and what? What? Electrophile form. B what? Br plus formed. Step 2. Br form here, which is electrophile. And be attack the what? The benzene to form carbonium ion. To what? To form carbon what? Carbonium ion. Am I going to write it here? Okay. Carbonium a what? Ion. That's what the scenario that's happening what in step 2. What is it now? Where is my benzene? This is the benzene that we have. At this level, we need to what? To show the bond of benzene. Don't use ring, because the bond will migrate. So this is benzene. This is what? Benzene. And where is what? Electrophile. This is the electrophile that is formed Br, and the Br is what? Is positive. Good. Since Br is positive, Abi, this is, here we have a what? A product coming on. Do you know what happened here? This is electron deficient. So by this pi electron attract this what? This electrophile, electron deficient species. So it will now have a benzene structure of this kind. This is double bond. This is what? Double bond. But not that is what? This bond A is already what? Attached to the what? To the bromine. We have it in this form. This is what? Bromine attached to it. And originally we have hydrogen here. The hydrogen we have there is what? Is this. As a result of that, of losing this pi electron out, this what? Benzene will become, it will have what? Positive ion here. So you now call it what? This is what? Benzene carbonium ion. This is what happened in what? In step 2. The electrophile attack benzene to form carbonium ion. And the last stage, which is what? Step what? Step 3. At this step 3, do you know what happened there? It's very easy at what? At step 3. In the step 3 here, the elimination of hydrogen ion. This hydrogen ion we have here, the hydrogen here, there is the what? Elimination of hydrogen ion to produce substituted parts. Let me write it there. Elimination of what? Of hydrogen occurred there. Elimination of hydrogen ion. And step 3, elimination of hydrogen. Yes, elimination of hydrogen. Abi, hydrogen to give or to produce, to give or to what? To produce the substituted parts. Let's check the last stage here. This is the benzene that we have, and we have the bond there. Here we have what? Bromine. Here we have the hydrogen, and we have our positive charge here. Yes. Can make me to shift this thing to this side. We have benzene. This is what? Bromine. Here is hydrogen. But on top here, there is what? Positive charge. And note, this is what? Arrow that leads to the formation of what? Of products. And don't forget that here, the product we have here, the catalyst here, that is take one bromine out of this from the beginning. It will now reappear here, Fe Br4 into the what? Negative. Good. At this level, this bond here will come back to this side. When the bond come back to this side, this hydrogen will be what? Will be empty here, but instead for the hydrogen to be what? To be empty, this bromine, originally we had three bromine here, one add to it. One out of this bromine that is have this negative charge will now what? React with what? This hydrogen. So when the what? The this bond come to that side, the benzene will have this structure, this double bond. This come back here, we have it back. The plus we what? Will disappear, and we have our what? Bromine here. Then H that react with one of out of the four bromine here, it will now give us what? HBr. Our catalyst will now come back FeBr3. That is what? The step 3. If you are asked to show the mechanism of this reaction, this is what? The scenario that is happened for this reaction to what? To occur. So you can see that is what? The F-ionic bromide that we used for the formation of what? Of electrophilic will later come back in. Catalyst does not dissolve in the chemical reaction. It's always what? Try to speed up the reaction. Please let me give you one more example on this. Yes. Example 2. Yes, example 2, let's look at what? The alkylation of what? Of benzene. Call it what? What? Alkylation of benzene. Alkylation of what? Benzene. Simply means what? Addition of what? Alkyl halide to benzene to give us what? Alkyl benzene and HCl as well as the product. For this kind of reaction, we always use aluminium as the plate. We always use what? Lewis acid as what? As the base, as a catalyst. Take, for instance, this is the what? Reaction of benzene react with what? Methyl chloride. If benzene react with what? Methyl chloride, and the product we have here of benzene given, product of benzene we have is CH3 plus HCl. Catalyst here is aluminium chloride. Aluminium chloride. Because we look at that one, we're using what? Iron bromide. It depends on what of the halogen we have to determine what kind of what catalyst we use. This is the reaction. If you are not asked, what is what the mechanism of this reaction? Can you solve it? Or the figure and solve it? Show me the mechanism of this reaction. Or as solve it. Let's go. if I want to stop this kind of reaction, first one is step what? Step one. Don't forget. What is step one? Do with formation of electrophile. What formation of electrophile? We will get the electrophile from the what? From the reagents. So this is substrate, this is the reagent, this is the catalyst. So the formation of electrophile by what? Reagents. So what is the reagent given? The reagent given is what? Methyl, yes now, Cl, Abi. What is the catalyst? Catalyst given is aluminium, given is aluminium Cl what? 3. That's the catalyst what? Given to what? To us. And the next thing we have is this. The way I did for what? The other one. The bond here, this chlorine will take out the what? The bond and react with what? This catalyst. So when it's what? The bromine, chlorine leave the methyl, and the methyl will have CH what? CH3. So if you have CH3 plus, you now have aluminium, Cl4, everything into what? Brackets, what? Minus. Because of this minus, because of the extra chlorine that is out there, this one that is used the what? The bond here, it will become plus. This plus that we have here is our what? Electrophile. And we know that the electrophile, so we are done with step one. The step two, the electrophile we what? We combine or we attack the step two. The electrophile we have here, the CH3, we CH3 plus attack benzene ring to form carbonium ion. So let us look at it now. This is the benzene ring that we have here. We have the benzene ring here. Then the what? The CH3 we what? We attack it. This is the what? The CH3, which is electro what? Electrophile. We attack the what? The benzene ring plus by attract this pi electron. So when the pi electron is being what? Attracted by him, what happen? We will have what? The is benzene structure will give us another form like this. You know, we have this bond remain here, this bond remain here. At this side, we have C what? CH3, and at this side, we have hydrogen. Don't forget, on top here, we have carbonium what? Ion. If you do, we have carbonium ion. This now leads us to the what? Step what? Step 3. What happened at what? At step 3. The step 3, the hydrogen ion here we what? We lose. Abi? We take out the what? The hydrogen what? Ion. Eliminate the hydrogen ion to give the substituted part. Step what? Step 3, but eliminate net hydrogen atom here. Eliminate what? By eliminating the hydrogen atom there, this carbonium ion we have here, we have it in this form. This hydrogen with this methyl. Don't forget we have what? Plus here. This hydrogen, this bond will come back to this side. So when this bond is what is coming back to that side, And don't forget our catalyst from the beginning of the reaction. Where is it? This is it. The catalyst we have it before is what? Aluminium Cl4 into bracket everything what? Minus. Good. So this man now what? When this is going to this side, it will now try to what? To attract himself to what? To this hydrogen. By doing that, you will have what? Carbonium with the benzene will lose the what? The positive charge and it form a new compound called what? Methylbenzene, which is known as what? As toluene. Plus, if the one chlorine here will react with what? With this hydrogen, we have HCl plus aluminium Cl3. So this is the what? The product form. And the product form here is called to what? Toluene methylbenzene. If you are asked to write or to explain the mechanism of this reaction, this is how we what? We do it. So we are done with what? Elimination, substitution, reaction of the what? Of elimination, substitution, reaction mechanism. Electrophilic substitution reaction mechanism. The next one is what? Is the nucleophilic. We are still on substitution. We have done free radicals. We have done electrophilic now. The last one is what? Nucleophilic substitution reaction.